Aloha. Going to explain the source of this energy using the scientific theory or teachings or ideas or concept. Okay, first of all, I want to go back and go over the absolute zero thing. Absolute zero is 459 degrees below zero. Every degree above 459 degrees below zero is demonstrating the presence of excess energy. That energy is not a property of matter, as we are taught. Now remember, a thermometer now becomes something else than we think it is. We think it's measuring temperature. It's actually an energy measuring device. Temperature is the quantity of energy in any given space. So here you see 80 degrees Fahrenheit is actually 539 MOE, measures of energy. So when it's 80 degrees outside, there's an enormous amount of energy. And even at 100 degrees below zero, the temperature would still be 359 MOE, measures of energy. Okay, let's go on to the next thing. This is very important. Now we understand that this energy in the air, this heat, is actually a form of electricity. And I'm going to show you this. This is confirmed by scientific research. There's something that's referred to as baseline current, or residual current, or background current. Now the common name for this is density. And actually, a fellow named G.G. Becknell stated a small Faradaic current density flowing through an electrode under conditions when zero Faradaic current is expected. So in other words, he was finding current in wire that shouldn't have been there. There's something happening to this copper. And then when the current is run through the wire, and there should be no more current, it immediately recharges itself, like a self-recharging battery. So there's always current in this wire. Now, they tried to blame this on impurities in the copper wire, which, okay, so there's impurities in the wire causing this excess electrical current. What impurities? In what quantity are these impurities? And if you increase the impurities, do you increase the electrical residual density in the wire? Well, see, none of this stuff is explained simply because they're trying to make excuses for why this electricity is here. We'll say, well, gee, there must be some kind of contaminants in there. It's causing this electricity. Well, of course, it's ridiculous. But they have to tell you something because scientists do not like to say, I don't know. It's not in their vocabulary. So they make up something really sneaky or convincing to, just like the temperature. Temperature, they say, is a physical property of matter. Of course, it's not. So they tell us things that we can't disprove, and they're very difficult to challenge. So they hope you don't ask the right questions. Okay, now the important thing about this is this density. That's really not true. It's not density. What it is saturation. Heat is saturating everything. This energy from the sun comes down, and everything is warm. There's nothing in here that's 459 degrees below zero, I can assure you, and you know that yourself. So everything has this heat, electricity in it, touching it. Everything is saturated. It's like full. It can't take any more. Well, copper seems to have one of the elements that has a peculiar ability to absorb a little bit extra. It's like a energy sponge. So, and it's measurable. It's measured. They call it density. They call it background energy. They call it residual energy. They call it baseline current. So it's there. It's real. It's measurable. And I'm just telling you, it's not density. It's not background current. It's saturation. The copper wire and everything is saturated with this electricity. The copper wire saturates extra. Now, what can we do with this? Can we use this? Well, actually, yes. In order to understand how we can use it, you have to understand how induction works. Well, at least the understanding of induction make it a little bit easier. And induction is another magic word. They say, oh, you get this transformer here, and you run power into one side of it, and then you have another set of, you have two coils of wires. They're not connected. You run wire through one, and let me explain it in a different way. Induction. Say, for example, I take two water hoses and I lay them side by side on the ground. And I run water through this hose, and then somehow I induce water to flow through the other hose. And they're not connected anywhere. You'd think, oh gee, this guy's performing quite a magical thing, but actually it's not magical at all in the electrical world, because all around you, this is called induction, where you induce electricity to flow into this wire when you run electricity through this wire. Now, this is important to understand the correct definition of what induction is, because in order for there to be induction into the second wire, the electricity has to already be there, just like water in the hose. You can't make water flow through the second hose if it isn't already there. Right? Okay. So I'm just saying, with this heat, electricity, and with the density, you now have the ability to perform induction. You can make the electricity move through the wire. Now this is really important, because you see how these things all work together, and they're logical, they're simple, it's not something over your head. Anybody can understand this. Okay, so you're running electricity through there. Now, when the electricity is going through there, electricity is like going this way, and as electricity is moving this way, where the electricity is, there's actually a magnetic field forming this way. This is very interesting, because it's this magnetic field which causes this other electricity to move too. That magnetism. Now people will say, well, you've probably seen, this is kind of a rough sketch, but a magnetic field is kind of like a, this figure 8 shaped thing around a magnet. Here's a big stack of magnets. So right now, this has a very powerful magnetic field. I don't know if any of this will work because it's stainless steel, but yeah, it's got this field, and you can, if you have any metal object, as you get it close, it'll pull. Now, a lot of people go, wow, this is really mysterious, this energy in a magnetic field. All these atoms are aligned, but what's really happening with the magnetic field is that, this is, not too many people that know this, but the magnetic field, of course, is going around like this, but where's that energy coming from? The energy is coming from the magnetic field is actually spinning. It's spinning so fast, it's spinning probably near the speed of light, I would guess. And you cannot see this except under very special circumstances. So it's that spinning, just like the Earth is spinning, and the Earth is creating, by that spinning, it's making a magnetic field. It's making gravity. So this is actually sitting here, spinning really fast. Okay? And so when it's spinning, it's like a motor. And that spinning is drawing in this saturation. So what you can do is, what science has understood is that you can place a copper wire next to this magnetic field, and if you can move one or the other, if you can move the wire or if you can move the magnet, you can collect this extra energy and get it moving. Now I have to explain something else to you about that, because it won't move unless it has somewhere to go and it has some work to do. So you can have this thing spinning here, and all this electricity is available, but you can't use it unless you're. It doesn't just spill out all over the place. You have to have, it has to be performing a function, which is for our benefit. This is part of how induction works. So everything, just about all of our electricity really comes from induction. And everything around you, you've got all these transformers that are based on induction. Your cell phones, your shaver, your lawnmower, your car, they have inductive transformers in them. Your car coils. Okay, so you understand about how the magnet works now. This magnet is actually a motor spinning really fast. You just can't see it because it's not in our dimension. The motor part is not visible in our dimension. Some people can see it with their mind's eye because they can see into other dimensions. I shouldn't say dimensions. The truth of the matter is that reality. In reality, you can see this working. But we're not in reality, and that's a whole other video. Okay, so now we understand the saturation part. Everything is saturated. Okay, so how do we collect this energy? We need a high frequency of over 20,000 hertz, and here's the reason. When you pass electricity through this wire, say you put in a tablespoon of electricity in here, and it's going to come out over here, and when it comes out over here, it's actually going to be a tablespoon plus a little bit. That little bit that was in there before is now part of this part, and then instantly the heat electricity goes back and it resaturates the wire again, so now it's got this extra charge. Now imagine doing that with a big coil of wire. This coil of wire is saturated. It's oversaturated. It has excess saturation. So you run a little bit of electricity through here, and it goes through, and then as it goes through, it takes what is it with it, whatever is in there. So that's where the free energy people call. You can't get free energy from a Tesla coil or any kind of inductive coil, but you can because it's already there. It's in the heat. It's in the electricity of the heat. Now, so let's say every second you spend half a second putting a teaspoon of electricity through here. It comes out at the end, and it's got an extra drop or an extra tiny bit of a drop, right? So what can you do to get out more? Well, what if you push the electricity through here 100 times a second? Well, each time it goes through 100 times, it's going to get a little bit more, right? What if you go through 1,000 times a second? Well, instead of having one drop or 100 drops, you got 1,000 drops in your cup of water. Okay, so now people like Donald Lee Smith said you got to get it going through there 20,000 times a second or more, and then things start to happen. Well, think about it. If this thing saturates 20,000 times in a second, and you're pushing electricity through it, and when you get to the end, you're going to use the same amount of electricity you did if you ran it a half a second every second. You're going to use the same amount of electricity as if you do it 20,000 times in a second. You're just putting in smaller segments of the electricity. You're just breaking it down into smaller pieces. But in the process, you're collecting all that extra saturation, that density they call it. We should call it saturation. We should call it what it is. But they didn't know. So now you see where this current's coming from? You're going through here 20,000 times a second, and you're gathering up all this extra saturation. Now the second thing is voltage. In order to increase the magnetic field and to increase the quantity of the available electricity is the voltage factor. As you increase voltage, there's almost every time you double voltage, there's almost a quadrupling of the available energy. So that's why you have Tesla and these people building these coils that are high voltage and high frequency. You combine those two factors, you get over 20,000 times a second, and you get over 3,000 volts. And all of a sudden, you start collecting more energy than you're actually using if it's done properly. So that's how it works. It's very simple. Now another thing would be the surface area. As you can see here, this has a lot of surface area. There's a lot of material to go through it. And so you'll see in Tesla coils, you'll see these big capacitors and big coils and things. And the reason is because the surface area. Think about saturation. Okay, this piece of wire is saturated, but how much has it got really? But if you take something like a big old adjustable capacitor like this, where it has a lot of surface area, all that surface area is going to be saturated too. Now, would you rather take the saturation from a little piece of wire or from big surface area? So we need surface area in these designs. We need big capacitors. We need very large grounds for all the current to flow easily and have lots of access to that energy. So this is how it all works. It's really pretty simple. The saturation and surface area work together. You can see now, I hope, why. Because more surface area, more quantity of saturation. And of course, the ground, the copper. You know, people they they take a little spike, and the copper spike, they stick it in the ground, and that's their ground. Well, it doesn't have enough surface area. So a lot of people now are learning to bury these big car radiators in the ground, get them down there about 3 feet, and get a good, good connection to them. And think about it. Think about the surface area on a car radiator. It's enormous. It's got all those little, little places on it. So you get that down 3 feet in the ground where the good grounding field is, and you have access to flow. You have access to surface area. So it's all complementary. Okay, and then Donald Smith, of course, showed us about the 20,000 hertz. And also another thing you might want to check out to confirm what I told you right from the very beginning, that the heat in the air is electricity. And there's something called acrylic lighting. It's just purely an ornamental. People buy these acrylic lightnings. They take a piece of acrylic and they subject it to some radioactive field, and it impregnates electrons inside of there. And you can look at it, and it just looks like a piece of clear acrylic. You can look right through it. But you take it with a hammer and a nail, and you just tap it with a nail, and all the electrons pour into the nail, and in the process, it burns like a lightning-like pattern into the acrylic. And this shows exactly what I'm talking about, is that the Tesla coil is doing the same thing. It's condensing the electricity in the air, and as it gets closer and closer to the coil, it gets more thick, the spikes of energy and electricity. And it's identical. It's just the same way lightning works, is that the electricity is condensing. Okay, I hope I answered most of your questions. Thanks for watching.